Awesome.
Man,
So
hey
640.
class. Welcome. So I think we spent some time talking about DAOs. That was fun. Hopefully you found it engaging as I did. I'm a big fanboy of DAOs and what they could be. But let's roll back into what today is about. So today, I am very excited to say that we have a member of the Algorand Foundation who's going to tell us all about smart contracts in general and at large. So this is more than just like talking about Algorand specific contracts. This is talking about contracts in general, what they can and cannot do, as well as then more specifically what Algorand can do as a platform to host your smart contracts. So with that, I might bring up Fabrice from the Algorand Foundation to come join us and say hello.
So hi,
Hey.
I'm Fabrice. Thanks, Dan, for inviting me to your class. Yeah, so I'm working at the Algorand Foundation, and by like education, I'm a cryptographer. I have a PhD in cryptography, but I'm also working on helping people like using the Algorand platform and teaching about smart contracts. And as Dan said, we start with really a general overview of smart contract, like what a smart contract. Oh, sorry, what I forgot to say is that if you have any question at any point, don't hesitate to raise your hand or write a question. And yes, and like Dan, if you see anything and need to raise my attention, I might not be necessarily see too much
Absolutely.
of that.
I was about to
Yeah.
say, Manon or I will definitely be watching the chat for you.
So yeah, so I will start with a general overview, and then I will do a deep dive in how it looks like on Algorand. I will do a quick comparison with Ethereum just to give you an idea of what's happening there. And I will end, if I have enough time, with explaining how you use actually smart contracts in the real world, how you use wallet for them, and even show you a quick demo of a real DApp with fake money, but still real. And okay, general overview of smart contracts. So what is a smart contract? So at the core of it, a smart contract is really just some small program that live on the blockchain. So it's really nothing more than that. And essentially, this small program can interact with the data that you have on chain. And there are many, many uses of smart contract. I'm sure that you already have been presenting some, but here, like some example, like the DeFi application, so decentralized finance. So normally, as you know, finance is very centralized by bank, stock exchanges, and things like this. And the DeFi smart contract are essentially a way to get rid of the central trusted authority, like the bank or the stock exchange, the New York Stock Exchange, for example, or I don't know, or similar things. And also, so DeFi app can allow you to exchange token for other token to lend money and things like this. Another example is crowdfunding. Like I'm sure you have all heard of this. Like it's very popular on the internet. You have a project or you have a cause that you want to defend and you want people to give money. And how do you do that transparently and also in a way that if you don't have enough money, then everybody gets reimbursed. Voting is the base of DAO that you have heard, like that was a discussion before. So voting is really maybe the core of DAO, and that's something that you can do with a smart contract. And more generally, you can do DAO. Decentralized name service, like the equivalent of Google, like currently, like if you go to google.com, you go to a name service system that will tell you google.com is this IP address. It's completely centralized by the ICANN. And the idea of that to use a blockchain and smart contract to decentralize this system. And another example is lottery or anything similar to a lottery like games. That is also something you can do with smart contract with a caveat that actually it's not straightforward, and you will see like this just in a few minutes. So I guess the first question you may ask is, if you dive a little bit deeper, is what can a smart contract actually do? The most simplest thing that a smart contract can do is read and write data on the blockchain. So a smart contract can really use the blockchain as a place to store data and to read it. And what it can store, for example, is votes, ownership of an asset, like I own this car or this NFT, if you heard of those. Properties of an asset, like this car is red, and exchange rates for between two tokens, between the USD and the Ether or something like this, and so on. a smart contract can also receive token from other accounts. So for example, if you do a crowdfunding campaign, what you want is that a user will just send money to the smart contract, and then the smart contract will keep the money until some conditions are satisfied. So a smart contract should be able to receive token from anyone. And obviously, if the crowdfunding campaign is successful, the smart contract can also send back the token to whoever needs to receive the money. So that's yet another thing that the smart contract can do. And finally, and this is slightly more advanced, a smart contract can also interact with other smart contracts, either just actually reading data. So smart contract A want to read the result of a vote of another smart contract, or want to read the price of another exchange smart contract or something like this, or even taking action, like a smart contract may want to that has money may want to actually like send its money to another smart contract or do things very complex like this. So that's what a smart contract can do. But what I really want to insist on is what a smart contract cannot directly do. And I want to insist on that because I think there is a lot of confusion in especially if you look at newspaper and like regular news, you will see that you have the impression that smart contract can do a lot of things that in truth they cannot do. And the first thing a smart contract cannot do is really interact with the outside world and with other blockchain. So a smart contract really lives in the blockchain it is designed for. See, if you have a smart contract on Ethereum, it lives on Ethereum. If you have a smart contract on Algorand, it lives on Algorand. And it can access a lot of things on its blockchain, but it cannot access the outside world. It cannot read a website. It cannot go to google.com, weather.com, or like the website of the NASDAQ to know the price of the NASDAQ. One example that a lot of people talk about and that is very difficult to achieve in that context is that I'm pretty sure you have heard of it, like many people said, smart contract will fix issue with insurances. Like you can create insurance smart contract, and this insurance smart contract will automatically reimburse customer if there is a storm and their house is destroyed by the storm. But that seems very difficult. That seems very, very difficult because first, how does the smart contract know that there is a storm? How does the smart contract knows how much damage you have to your house and how to evaluate the price of this damage? So there are solutions for that. Like for example, the insurance company could input themselves the data, and that can be useful at some level for transparency because you can check that the insurance company is inputting the correct data, and then automatically the smart contract from this data would reimburse the customer. So that adds some transparency and auditability. But at the end of the day, the smart contract cannot directly access this data. And really, there is a need for huge infrastructure around this for it to work. And actually, one part of this infrastructure is what we call oracle and bridges. And this is kind of a solution to this question. How does a smart contract interact with the outside world? And Oracle, so what an Oracle does, it essentially allows other entities to give information to a smart contract. And it's quite a very complex question. And it's still, I would say, at an area of research of how to do it the best way, the most trustless way. And a bridge, just to define the word on the slide, a bridge is just an oracle to access data from another blockchain, essentially. So another thing that a smart contract cannot directly do is working on secret information. Everything on the blockchain, absolutely everything is completely public. There is no secrecy. And everything the smart contract does is public. Like the smart contract is really just a code that is public and anyone executes on, and the input are public. So when people are talking about using smart contract to store medical data, that seems very difficult to me. Very, very difficult. It's not to say that it's impossible. Like there are things you can do. There are advanced cryptography techniques that you can do. Like there is some recent paper we had actually with Secret on the Blockchain, which can maybe in some setting provide a solution for this. But it's not straightforward, and it's definitely not something you can get easily. And don't even, I would say not a good idea for a project for this class, I would say, most likely. Another caveat to this restriction is that combined with ZK snark, you can have some privacy in some setting. For example, so ZK snark is some very advanced cryptographic system called zero knowledge system. Anyway, but it's using this very advanced cryptographic primitive, like you can provide some form of transaction privacy in some setting. But again, it's restricted. It does not allow magically to store medical data, which are extremely sensitive. The final thing that the smart contract cannot directly do is direct access to randomness. Like smart contract is a completely deterministic piece of code with the input are deterministic. So it is the complete opposite of randomness. And there is no way for a smart contract to directly compute randomness, but there are ways to do it using randomness oracle using external information once again. But it's not straightforward and it requires really understanding things. Okay. So now that I think we have a better idea of what a smart contract is, can do, cannot do, let's see how we interact with a smart contract. So we've seen a smart contract is a piece of code in the blockchain. How do I interact with the blockchain? Transaction. That is really usually what you do. Like a blockchain is something to store transaction, and that's no difference to interact with a smart contract. To interact with a smart contract, you make a special transaction. On Algorand, it's called application transaction, but it's essentially the same on all the blockchain. And that's how the external world is interacting with your smart contract. And that's also how you deploy a smart contract in the first place in the blockchain. Oh, I see. So fixing insurance and medical data seems difficult. Yes. But do you think blockchain will one day resolve these spaces? I think it's possible. Like, I think the technology is not ready yet. Like, I think the secret on the blockchain, like there are ways. Like currently what a blockchain gives you is really a public ledger, like something completely public. But there are other technology in cryptography, like secret sharing and things like this that can be used on top of that. And we can imagine that we have the blockchain can provide the same privacy as it provides trust in non-forking. But there is work to be done. It's really not something straightforward, and definitely not. Yeah, it's. I would say it's still at the essentially research level, early engineering, like not something that should happen very, very quickly. But I think it can in the long term. Yes. Okay. So now that this was like all of what I told you is really completely generic to all the blockchain, I would say. And now let's dip a little bit more in the Algorand smart contract. Before going too deep, I want to define the notion of account and smart contract. So I'm pretty sure you all know what an account is. But just to recall, like usually, at least a basic account on any blockchain is defined by a public key, signature public key, and a secret key. The public key in Algorand look like this PU 3KO blah 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 string, and the secret. So that depends a bit on the blockchain. Like Ethereum is different. The secret key is usually like 24, 25 words like this. When you have the public key is public and is the address of the account in general. And the secret key should be kept secret, and that's what is used to issue transaction. So to issue transaction, you sign it using your secret key. You should never reveal it, otherwise people could steal all your money. The secret key can also be used to call, deploy, update, delete smart contracts. Because doing that is just another kind of transaction. So really an account is really just like this, is really basic account at least is defined by such a public key. And essentially what an account does is that it holds the balances and in the case of Algorand, the local state of the smart contract. So on the blockchain, to each account is associated its balance. Okay. So for question of multi-chain, this is a bit more. So I mean, okay, so I will come back after talking about this at the end because remind me later because it's a bit orthogonal to this. So that's on Algorand. This is an account. Now, a smart contract on Algorand is really a program living on the chain, and an account can be used to send transaction to interact with the smart contract. And so on Algorand, the account and the smart contract are different. Like if you are talking about Ethereum, actually they are the same. Also, essentially the top one would be called, now I forgot the name, end user account, now I forgot, but and the bottom one would be, but they look the same. But in the case of Algorand, it's very simple. Like an account on a smart contract looks completely differently. An account is defined by this public key, and a smart contract is just defined by an ID, like an application ID like this. So if you look at Block Explorer, which is how you read the blockchain, so here it's one of the Algorand Block Explorer, an account looks like this, where you have an address, you have the balances. So an account can have multiple tokens, not just its own token, and you can see the transaction that happens. For example, I don't know if you see my mouse or not, actually. But if you don't see my mouse, you can see on the right, like the transfer of, oh, we do. So you see the transfer of algos. This is a transfer of algos. So this is a transaction sending 0.3 algo from this account to some other account. And this is an application call. This is a transaction that interacts with a smart contract. So that's what an account looks like. And this would look like the same in all the blockchain. And an application on the other end is on Algorand really different because it is defined by an ID and some parameter, but there is no transaction associated to it. Okay. Before going further, I need also to introduce something that is like not at all specific to Algorand, that is very important in general, which is the notion of state of a blockchain. So I'm pretty sure you know what the blockchain is. Like it's a list of blocks. Each block has transaction, and that's the name blockchain. And this is very, very large. Like for Ethereum, last time I looked at it, it was more than 9 terabytes. And for Algorand, it's close to 1 terabyte. So and Algorand is very young. So you can see that this grows crazily fast and it becomes huge. On the other hand, the state of the blockchain is much smaller, and it's essentially a database that represents exactly the state of the blockchain. This means things like the balances of each account, the consensus keys, like used for the keys in case of proof of stake. In case of Ethereum, you don't really have this, or the state of the application, like the storage or state of the application, and all of this. So the state of the blockchain is not a list of all transactions, but just like the important information about the account and the application, if you want. And usually the state of the blockchain is stored in a database in each node being just a server in a blockchain. And the idea is that the state of the blockchain can always be recomputed. If you take all the blocks and execute all the transactions, you can recompute deterministically the state of the blockchain. Like you can figure out what the state of the blockchain is. It's very clear. Like at the beginning, for example, Vitalik, okay, I'm sending a random thing, but Vitalik has a certain amount of Ether, and it transfers 5 Ether to a new person. So now Vitalik has this number minus 5 Ether, and this new person has 5 Ether. And so you can update, from the list of transactions, you can easily update the list of balances. Actually, here we have a really concrete example. Alice, for example, sent 2 algos in a transaction. So algos is a currency of Algorand. It's a native token of Algorand. So Alice sent 2 algos to Bob. At the beginning, in the state, let's say that Alice had 20 algo and Bob had 7. And then when the transaction gets added to the block and is finalized, then the state is updated to Alice has 18 algo and Bob had 9 algo. And what's very interesting to remark is that when you did this transaction, the full blockchain increased, like you have 1 more transaction. So it becomes much larger. But the state did not increase in size. Like we just changed 2 rows in the database of the state, but we did not add any row. So some operation will always add rows, like if you create a new account, but many operations just actually update the state. That's why the state is so much smaller than the full blockchain. And And actually, yes, most of the nodes on the blockchain only store the state and not the full blockchain for this reason. So that was very generic, like for all the blockchain. So now we really dive inside Algorand specific thing. So in the case of Algorand, an application or smart contract can store data in what we call its global state. So each application has an associated global state, which is a row in this big database of state, and or multiple rows. And the global state can contain up to 64 key value pair. So an example of what you want to do, for example, is suppose that you have a voting application. You will want to have a key, which is, for example, the tally of all the votes yes, and the value, which is the tally. Or you would want to have like the address of an admin that is allowed to maybe decide who is a registered voter and associate it to the value, which is the address. And this is stored like directly in the state like this. The reason why on Algorand you have only 64 key value in global state is really for performance. Like Algorand is created so that one block every 5 seconds, and the transaction, as soon as they appear in the block, they are finalized. There is no forking, no temporary forking, no nothing. Like a transaction in 5 seconds, it's finalized. It cannot ever be removed by a fork or anything like this. There is never any forking. And the time to evaluate a transaction is very, very short because most of the time is used for all the nodes to agree on the set of transaction. So essentially, since there is so much little time, there is quite strong restriction on the amount of state that can be accessed, and also and there is also limitation on the state itself to restrict the size of the state, the database that each node needs to store. So all of this is for performance reason, but as things improve, we are able to potentially like remove some of this restriction. But in the meantime, you can say like 64 key value is just completely useless. Like there are many things you cannot store. You cannot store, for example, the list of all voters or the list of all votes. That would be an issue. So actually, it's Algorand already has a solution for that. It has an additional way for smart contract to store data, which is a local state. So the local state essentially is another way for the application to store data that is associated to each account that opts into the application. By opts in, I mean it's a special transaction, like it's a special transaction that the application make to indicate that I'm willing for the application to store information for me. And the local state allows up to 16 key values. So an example of things you will want to store in a local state in a voting application is, am I a registered voter? Is this account a registered voter? Is this account, what is this account voting for? So you may think that this local state and global state is very restrictive, but the truth is that actually most applications you can do on Ethereum, you can port them easily on Algorand. You just need to rethink slightly how you design it and use more of the local state rather than on Ethereum, where you would push essentially everything in some form of infinite global state. One thing that is very important to understand is that even when we call something local state, we don't mean that it's local to the wallet or to the computer, or that is generating the transaction, or that is holding the account. It's really everything is stored on chain. And the local state is just like one other row in this big database state, in the big state of the blockchain. So here, for example, if this account voted yes, you have this row, and if it's a registered voter, you have this row. So everything is in the big state of the blockchain, replicated by all the nodes. And more concretely, another question we can ask ourselves is, who can read and write this state? So the global state and the local state of any application A can only be read and written by the application A itself. And an external application, and another application can only read the global state of other applications. That's necessary. Otherwise, you would create a different application that modify the state and like cheat on the vote and things like this. So you absolutely don't want that. So only the application itself can read and write its states, which is, by the way, the case of all the blockchain I know too. And the specific part of Algorand is the separation between global and local. And one thing that is important to understand is that the local state for account U can be modified by application A, even if the transaction was not made by you. Like the application A really can control all the local state of all the accounts that opted in. It has really full power over it. No need for the you to do anything. And in particular, even if you know the secret key of the account you cannot modify the local state of A. Like the local state of A is really completely only controlled by the application A. Okay, so in Algorand, actually, we have a little bit more detail that I need to introduce is that with the smart contract is actually not just a single program, it's two programs that I will explain just after why to program. And these two programs are written in a language called TIL. And at this point of the talk, I think it's very important to understand how dApps or how application and decentralized application are made in general. So, and this is not limited for Algorand, it's true for all the blockchain too. So usually when you have when you want to create a decentralized application on any blockchain, you want to write a smart contract. Remember that the program that lives on chain, and you want to interact with it using application transaction. So the smart contract is always written in a smart contract language. In the case of Algorand, it's TIL, or it's generated by by a Python script, which is called PyTIL. And this is really done using this language and without any interaction with the network or anything. You don't need an SDK or anything like this. It's really a specific language that writes a smart contract. On the other hand, to interact with the smart contract, you usually need the SDK of the blockchain. So in the case of Algorand, we have SDK for Python, JavaScript, Go, Java. So you can use any language as long as there is an associated SDK for the blockchain. And you need to connect the SDK to the blockchain using a node. In the case of Algorand, the node is called AlgoD endpoint. So yes, so all Algorand application have, they have a creator, like the person creating is stored in the application state, and the creator may or may not have special privilege. Like in general, if at the beginning you would allow the creator to delete the application and update the application maybe, but not even necessary. Like a pure DeFi decentralized DeFi app, the creator would have no special privileges compared to other users. And yes, and then all users can opt in into the local state. So all of that can opt in to allow the app to store local states associated to them. Yes, and yeah, exactly. So the creator may the updates the rule for updating a smart contract on Algorand is also code. So the code can be the creator need to be the sender of the transaction, which is the most basic thing. The code can be reject at all costs. This means that no update is possible, but the code can be much more advanced than that. It may require some very advanced authorization structure. It can say for the beta period of 3 months, the creator is allowed to update, but after 3 months, the creator is no more allowed to update. So you have all the flexibility of a normal code to decide whether an application is updatable or not on Algorand. So actually, concretely, the way it works is that the way you communicate, as we have seen, to an application, like on any blockchain, is making a transaction. And on Algorand, you have a specific type of transaction. The default type is no-op, which is the one used for creation. And this is usually what you do to interact. But you also have like the opt-in, which is to say, I allow you to use my local storage. The delete and the update application type, which allow to delete or update the application. But again, for all this type, the approval program is executed and it may say, no, I reject it. So when we have an update type, the approval program may say, no, I reject it because the policy for updating is not satisfied. We also have the closeout, similarly to this one, which is the opposite of the opt-in, which is I don't want anymore the smart contract to store local storage. And the smart contract may allow or reject this. Like, for example, when you vote, the smart contract should not really allow you to close out before the end of the vote and the full tally. But for some reason, on Algorand, sometimes the user wants to get out of the smart contract, whatever the cost is, whatever the consequences are. And so there is this force clearing local storage. And in that case, a special program, which is a clear program, is executed and allows the smart contract to fix things as much as it can, but it cannot reject. So an example in the case of voting is that if the voting is not finished and the person already voted and then clear, what you want is that the clear program to actually fix the tally and remove the vote of the user. And for example, that's an example of what you may want to do. So, okay, so all of this shows you how to use a smart contract on Algorand to store data on chain and read data on chain, like this global storage, local storage. So it really allows you, like from all I told you already, you should be able to do a simple voting application. But often you want to do much more than that. And we have seen that smart contract can do, for example, can receive and send tokens. So how do you do that? So in the case of Algorand, the way it works is that a smart contract can control what's called an application account. So remember, user interacts with the smart contract with transaction in purple, and user have accounts, and the smart contract has an associated application account that, contrary to a normal account, where the way when you do a transaction from a normal account, you need to sign it and you need a secret key. The application account is a special account where there is no need for a secret key. The smart contract can just say, I want to issue a transaction from this application account, and it's issued. And that's how the smart contract can, for example, okay, sorry. So the smart contract, as usual, has an application ID, and the Algorand application account is a normal account, so it has an Algorand address. And anyone can send token to the application account. Like, for example, if you do a crowdfunding and people want to send money to your project, they would send token to the application account. And the smart contract can also issue token, like send token out of the application account by using the inner, what we call inner transaction. So the smart contract can issue inner transaction from the application account to whoever he wants. Yeah, so remember, the normal account, the transaction is by a secret key, and application account, the transaction are issued by the smart contract as an inner transaction, and there is no secret key involved, because as we have seen, smart contract cannot keep secret key. Smart contract are public. Okay, so we have seen essentially how on Algorand, the smart contract can read and write data on the blockchain using global and local state, can receive token from other accounts, can send token to other accounts. So they receive token in the application account, they send it via inner transaction from the application account. And finally, how they can interact to other smart contracts. Actually, they can use inner transaction, like the transaction from the application account, to make calls to other smart contracts. But I cheated a bit, because it's true that people can send money to the application account, but how does the smart contract knows about it? Know that it receives a token. And for that, I need to do like a small segue into ASA and atomic transfer, which are like two features of Algorand which are quite useful. So the first feature I want to introduce is ASA. So I don't know if you have seen it on Ethereum or not, but on Ethereum, you have this notion of token, ERC20, ERC721, ERC1155, and so on. Yeah, so this is, they say, the equivalent of this token, which is essentially a custom token that anyone can create. Example are loyalty program, like you want to create your own loyalty program, stable coin, a coin that mimic a dollar, for example, the USDC is a coin on the Ethereum or on Algorand that mimics the dollar. And so that's a custom token that is independent of the native token. The difference between the Ethereum version of this custom token and the Algorand version is that on Algorand, the token is really baked in the protocol. So it's really the same cost to transact with this token as a normal algo-based token transaction, and there is no need to write any smart contract. It's really just completely baked in the protocol. It's also very easy to create such a token. Like there's on the website, you do 2 clicks and you get it. And when you have such a token, like suppose you have USDC, which is a token representing a dollar, you may want to exchange tokens for each other. This is one of the most basic DeFi applications, like exchange. Like Alice may want to send 1 algo to Bob, and Bob may want to send 20 USDC, like a token to Alice. The issue is that if you do that, I mean, how to do that? Let's suppose that Alice send 1 algo, it's possible that Bob will never send back the 20 USDC. And if Bob starts by sending the 20 USDC, it's possible that I never send back the 1 algo. So on other blockchain, you would need to write a smart contract for that. On Algorand, there is something that's called atomic transfer or group transaction, which allows you to group this transaction together so that either all the transactions succeed or all transactions fail. So when you group these 2 transactions together, either Bob gets its 1 algo and Alice gets 20 USDC, or nothing happens. And there is no need to write any smart contract or anything. It's very, very easy on Algorand. Just you essentially mark this that these 2 transactions must be executed together, and they will be executed together or fail. And actually, here I've shown a very simple case, but you can, any transaction, including application call, can be part of an atomic transfer or group transaction. And we can even have up to 16 transactions, so very complex things going on. And the way you allow a smart contract to receive a token on Algorand is by making a group transaction of 2 transactions. One is the funding of the application account. Let's suppose that Alice wants to send 1 algo to a crowdfunding app, and the other is the application call. And essentially what's happened, I don't want to go too much into the details, that the smart contract can actually inspect all the transactions in a group of transactions and see that it got paid 1 algo. And here it's a very important time to tell you one thing that is usually very important in general, is that on all the blockchains, smart contracts cannot act by themselves. Smart contracts are piece of code, but they are only acting when they receive a transaction. So that's why you cannot just have like in the case of Algorand, the 1 algo transaction automatically triggers the smart contract, because it's not triggered by this transaction. You need really to group the 2 together and have the smart contract manually look at it in the group of transactions. So that's just an aside that is usually important to understand, especially if you think about like creating like scheduling payments or things like this. You always need to design it so that it's not triggered, but it's like people pulling out from it. But it's really an aside, sorry, like maybe I'm confusing you. So let's go back to the main thing. This is how you receive token in a smart contract. Let's see everything we have seen up to now in an example of crowdfunding. So I talked a bit about crowdfunding. I'm pretty sure you know about Kickstarter, for example. So like it's a place where a creator proposes a project. There is a fund goal to reach. I want $10,000, an end date by end of February. Then donator can fund the project. And at the end, if the fund goal is achieved, all the fund goes to the creator. And otherwise, everybody gets reimbursed because the creator has no way to do the project if he does not have enough money, or if they do not have enough money. So concretely, the creator they will start by sending by creating the smart contract. And in the smart contract, in the global state, we would have all the parameters of the crowdfunding. sorry, I got a bit confused in my head. So what I wanted to say is that Kickstarter exists, but it's not decentralized. Like there is a central authority that manages all of it, and smart contract allows you to completely decentralize it, so there is no central authority. The blockchain is controlling everything. And here is how you do it on Algorand. You would have like the smart contract that is like created by the creator. And inside the smart contract, you would have in the global state the information about the crowdfunding opportunity. And that people can fund the project by sending money to the application account, like token to the application account, and in the same atomic group calling the smart contract to tell that I funded the smart contract, and automatically, and we make also this application an opt-in so that the smart contract can store some local state, and in the local state of the user that fund the user that is doing the funding, the smart contract will store the amount that the user gave. That's very useful because that will be useful later. So then, if at the end of the funding period, like at the end of the crowdfunding period, if there is enough fund received, which I forgot to say is stored in the global state and updated every time someone funds there is this current funding received state that is updated. So if the current funding received state is above the fund goal, then essentially the project creator will issue a transaction to a smart contract to get all the funding. And this will be done by inner transaction. On the opposite, if not enough funds are raised, then every user will send a transaction to a smart contract to get reimbursed. And that's where it's very important to have stored in the local state the giving amount so that the smart contract knows how much to refund each user. And it's important also to understand that on Algorand, but it's true for any blockchain. I mean, any blockchain I know, at least Ethereum too, is that you cannot have like the smart contract like starting reimbursing everybody automatically, because that may take way too much time. If you have 1 million users that funded, you cannot have a single call of the smart contract that will refund 1 million users. So instead, each user needs to come and ask for their money back. So that's how it works on Algorand. That's how it works essentially on all the blockchain, I believe. Okay. Okay, so I think I will skip that because wait.
So Fabrice, I think actually might be a great time to go ahead and take some questions from the audience.
Yes.
So it might be a great interlude. I don't know if Manon's around to maybe unmute and have some people come up and ask something, because I think there might be some in the class that were interested in asking a few things.
Okay, awesome. Did any of you guys have any questions to ask? Or everything good so far? Yeah? Go ahead. Yeah, just speak up. We're come close.
So you give the example of crowdfunding. A similar application I could imagine being like a bounty. So a company or a DAO or someone's like, complete this project and you get a certain amount for doing it. How do you prevent someone, just saying that the project wasn't completed to their standards, but then just using the work?
Yeah, so that's an excellent question. And that goes back to smart contract cannot know what's happening in the outside world. So smart contracts have no way to know whether the project has been completed successfully, whether the project, whether anything bad happened. Like, it's impossible. So I think usually the generic solution is oracles, but in this specific case, I think that what usually people are doing is that first, in the case of a bounty, the creator of the bounty can say yes or no. And if they say yes, great. Now, if they say no, it has not been successfully done, you most likely want to have like a set of jury, not sure, or auditor, or like second resort people that would be asked to have a look at what's happening. Maybe these people will have a cut on the bounty if they are called, but they would and there would be neutral parties that would be called vote on whether the project was successfully delivered or not. And so maybe the simplest solution is maybe you have like 3 such people, and if 2 people agree, then that's the final decision. So you need some external mechanism like that, because except if the project is itself a blockchain thing, something on the blockchain, you need something external that decides on it. And since it seems that only human usually can unfortunately decide, in which case you really need to have like some set of human like being able to say yes or no. I mean, you can, I guess, also have AI at some level making such decision outside of the blockchain and then signing in some cases, but yeah, that's a very good question. That's a very difficult. That's really quickly what you go into when you think about this.
No, that's really helpful. Thank you. I just imagine there could be ill will on the side of the person posting the bounty if they wanted, because to do that grading, or even if there's a console, it's like they already get the product. Like you need to get the product to actually see if it's to the standards, and then if they just say no, then they basically get the work for free. But that's a good point about creating maybe some sort of like outside console.
Yeah.
A couple other models that I've seen, a lot of time locks, right? So staging a contract such that there are waypoints in which you can basically have some pause before things are executed. So in injecting voting into this. So for instance, if the bounty issuer says, hey, I'm done, like I'm going to take my money, now there might be a week timeout where the community can say, actually, no, like you didn't fulfill whatever was going on. That does get really complicated really fast, though. You're in one of the deepest, darkest, I would say, theory research areas in blockchain right now, is how do we ensure that these oracles or outside data is appropriately managed on data, and the things that we want to happen out in the real world actually happen on chain. So yeah, jury mechanisms, time locks, oracles all play important roles in there. And I would also argue there's a lot of movement around identity. So maybe you, if you're just some pseudonymous account on a blockchain, if you associate that now very tightly with your in-person reputation, this might be another thing to keep you honest in what you're doing. So stuff like this.
Okay, awesome. Do any of you guys any more questions for this segment? Cool. We all good? Awesome. All right. I think in person we are all great. Cool. Thank you.
Okay. So thanks, Dan. And so I will go very quickly here. It's much more deep down about what's happening. Essentially, yeah, I think it's a bit too detailed. Essentially, till the language used on Algorand is a language which is a stack-based language. If you have ever seen that, and the short thing that is important for you to understand is that I want that you don't write in this language. Like this language look like this green thing. You actually write in a Python-like type of language, which is quite simple. And this is the documentation. And I want actually to show you directly how it looks like on the demo. Let me directly show you the demo I want to show you. So I want to show a demo that is extremely simple. It's a smart contract that every time you call it with the argument pay me, because every time you call a contract, you need to specify arguments or method, or like what do you want to do with the smart contract? Am I voting, for example? Am I registering myself? Something like this. So every time you call it with the argument pay me, it sends you 0.21 algo. So it's a very useless smart contract, but it's a very, very basic one just to see how it looks like on Algorand. And the way you do it, you write it in a kind of this Python language, which is really Python. And the main part of it is this switch or condition. And it says, if the application is created, so if the ID is 0, this means that it's created, then I just approve, because this smart contract does nothing. It does not store any state or anything. So since it does not store any state, no need to set up anything. But normally a smart contract at this point would like do something, which is set up the state, the global state, its global state, just to have things good. Then this smart contract is the kind of the smart contract which allows the creator to delete or update it. So this is a choice here. So if the ticks on completion, meaning that if at the transaction is a transaction to delete the application or update the application, I return is creator, so I return true if it's the creator, or return false, I reject if it's not the creator. Is creator is just defined as the sender of the transaction is the creator. And I don't need opt-in and close out, so I just reject. And the main thing is, if the first argument I'm called with is pay me, then I use handle pay me. And handle pay me is a transaction, remember, it's just sending 0.21 algos to the sender. The way you do it, you just say, I want to begin an inner transaction. I want to set its field to payment. It's a payment transaction. I want to do a payment transaction as opposed to an application call, or as opposed to sending another token, a token transfer, custom token transfer, ASA, it's called in Algorand. So the amount is the amount I want. So in algo, you use always the lowest denomination, which is like micro algo. Wait, I think there's 1, 2, 0. Anyway, now I'm getting confused. Wait, there might be 1, 0 too much, but I don't know what. Okay, I don't know. I'm getting confused slightly here, but okay, ignore me. I don't know why. I thought it looked like 2.1 algo, not 0.21. Anyway, and the receiver should be the sender. So that will issue from the application account the 0.21 algo transaction to the sender. And we can also log somewhere, like write essentially on the blockchain some message, which is I sent 0.21 algos, and then I approve it. Okay, so now to run this, so this is like the PyTil part, the smart contract part. And to run it, you need to write some code in some language. Here I use Python because I'm the most, I prefer Python to the other language for such a simple example. And I will show you quickly how it looks like. So first I need to get my list of accounts. Then I'm just displaying like, I'm not sure you see anything here. Cool. I'm just displaying the 2 account address. I got them from somewhere. And then now I'm creating the app. I'm deploying the application. Okay. And the application has a certain ID and an associated application account. Now, the application account at the beginning is empty because you just deployed it, like it's empty there. It does not get by magic algo, so I need to give some algo there. So you see that everything is real time, by the way. So Algorand is very, very fast. In 5 seconds, the transaction is completely confirmed and finalized, which is a big advantage of Algorand. So here I'm not even cheating. I'm not using dev mode or whatever. It's a real network. It's just 5 seconds. It's like no cheat. Everything is real time. And now the application account has 1 algo. The Bob, which is another account, has this amount of algo, and what I want to do is I want Bob to call the application with the argument pay me, and Bob should get back 0.21 algo. So that's what I'm doing. So the way I'm doing it is that I'm making an application transaction from Bob's address to the application ID with the argument pay me. And then I'm signing this transaction because, as you know, every time you do a transaction, you need to sign it to authorize it. This is for debugging, you can ignore it. And then I'm sending the transaction. And once the transaction is sent, it will execute the smart contract that we have seen here. And it will go there. It will realize that my application argument is pay me. It will execute end all pay me. It will go there, and it will issue a 0.21 algo transaction to Bob. And now if I print the balance of Bob, it has 0.21 more algo, and the balance of the application account has 0.21 less algo. Okay, and at the end, I just delete the application for cleanup. So this is really just what it is. So it's quite very simple to write smart contract, execute it. And big advantage of Algorand, I would say, is that it takes 5 seconds, finalize, no risk of fork, no nothing, real time. So that's what it is. And now I want to talk about something that is quite important in the last 10 minutes before I want to talk about two things. One thing is the notion of fees and constraints on smart contracts. And one thing is how to do an actual decentralized app on a wallet and how to access user accounts via wallet. So the notion of fee is something that is general for all blockchain. Like you need almost all blockchain. You need to have each transaction in every blockchain essentially has a fee that is paid, that is either burned or paid to someone. It depends on the exact detail, but the idea is that the sender of the transaction pays this fee in order to prevent essentially spamming. So it's a payment to record the transaction, and it prevents people from spamming transaction and use their blockchain to store a huge amount of data, or just prevent other users to use the blockchain. If you had no fee, somebody could just like create a lot of transactions that are useless, and nobody could use the blockchain. In the case of Algorand, the fee is extremely low. It's 0.001 algo, which currently is less than 0.1 cent. And as for any blockchain, there is a need still to handle cases where blocks are full. Like when blocks are full and you cannot add more transactions, you need to find a way to prioritize transactions. And usually on blockchain, what's happening is that the transaction with the highest fee are selected. So on Algorand, it's a bit different. If there is congestion, too many transactions, nodes will require a minimum fee that is much higher than normal. And the minimum fee is computed using this formula. But essentially, the idea is that if there's congestion, nodes will require a slightly higher transaction fee. And so people who really want their transaction to go into will need to pay a little bit more, and that will reduce the amount of transactions, which is what all the blockchain use. One point, however, that makes Algorand different from other blockchains is that it supports like 1,000 transactions per second and even more very soon. So congestion is extremely rare, will never happen. Like never happened. I mean, will never happen. Maybe not, because hopefully blockchain will be used a lot. But at least in the past, never happened to my knowledge. So fee really like deal with the fact that you really don't want the full blockchain to grow out of bound, and just the full blockchain is limited. Like each round can store only a certain amount of transactions. Each block can only store a certain amount of transactions. There is another thing that you want to control in general is the size of the state. Remember that the state is replicated between all the servers of the blockchain, all the nodes in the blockchain, as opposed to the full blockchain, which is only usually replicated in a few bigger nodes. So you really want to prevent the state to blow up. And the way Algorand does it is by using the idea of minimum balance. So you can think of it as a deposit. Like if you go to the swimming pool and there is a locker, usually what you need to do is to put your stuff inside the locker. You need to put a quarter And when you come back, you can open the locker and get back the quarter. So you pay a quarter as a deposit for using the swimming pool locker. And the idea is that it's to prevent people from overusing the locker, and some like kids, to prevent like some kids like to play and just like close all the locker for fun. And that's exactly the same for minimum balance in Algorand. It's really to prevent people to abuse the state and like create a lot of accounts, for example, or a lot of applications that would use up a lot of state, and that would blow up the size of the database that each node needs to have. And like the locker at the swimming pool, this is reimbursed when you stop using it. So if you delete a smart contract or delete an NFT or thing like this, then you get back your money. Yeah, I mean, that's essentially what I want to say. And that's not necessary. Another thing that you want to prevent in all the blockchain, again, is that you don't want a smart contract that takes a huge amount of time to run. Like if a smart contract takes 1 minute to run, this means that a block will take 1 minute to be created at least. And so that would make the blockchain extremely slow. So you need to have constraints on that. So on Algorand, the constraints are extremely strict. Essentially, it works using a budget per opcode and things like this, but I don't want to enter too much into the details. Okay. Just a quick word that all of what we've discussed up to now was using like PyTil and Til to write smart contracts. There is another way to write smart contract on Algorand. It's using Rich, which has the advantage, two advantages. One advantage is that it's guaranteed safety. So I don't know if you have been introduced to formal verification, but essentially it provides formal verification of certain properties. So you can prove, for example, that your contract will never lose money. Like there will be never money locked in your smart contract forever. And this is a proof. It's not like just a test like some people tried. It's not just an audit where some people looked carefully at the code. It's really something mathematical proof, really proof in the sense of mathematical proof, like the proof of the Pythagorean theorem. And another advantage of Rich is that the same code targets both Ethereum and Algorand. So no need to choose even your platform. You can, with the same code, you have both platforms supported. Okay. A quick comparison with Ethereum. So on Algorand, we have this slight difference that the smart contract is not an account, while on Ethereum, the smart contract is an account. The main difference from a developer point of view are the fact that Algorand take only 5 seconds for finalization. Like even on the real Algorand, it goes so much faster than Ethereum. And the fees are so much cheaper. They are independent of the complexity of the smart contract, and since there is almost no congestion, things are very, very cheap. Like even on Ethereum, fees are much higher because and they depend on the smart contract complexity. So you pay somewhat of a trade-off because the computation power that you have and the amount of storage that you have is much more restricted on Algorand than on Ethereum. That being said, I think that I would say almost all application like can be ported to Algorand. You may need to think a little bit more, like it can be slightly more complex to do. But everything that is very simple, like voting, crowdfunding, like all of this, no problem. Like if you want much more logic, like I don't know if you have heard of it, MakerDAO and things like this, might start becoming a little bit more complicated, but still, I believe it's possible with a new system. It just might require thinking more. But what you get in return of this thinking more is that the fees are much lower and the speed is much, much higher. Yeah, so in addition, the two things that Algorand makes slightly simpler than Ethereum is the atomic transfer. Like if you want to exchange two tokens, like it's done. Like you don't need to write a smart contract from that. And the custom tokens are also much simpler. So no need to write a smart contract, like, and it's cheaper to transact. Okay. I went a bit quickly because really what I want to talk to you about is the notion of decentralized app. So up now we have seen what a smart contract is. We have seen that you interact with a smart contract with transaction, but how does it look like in real life? In real life, the smart contract written as I told you, till, pi, till, OH, Solidity on Ethereum. But the interaction with the smart contract is not like this. It's not like this Python script. Like nobody would be using DeFi app if they had to write something like this and enter their secret key there. And no, it's done by a clean website, web app. This website connects to the blockchain via Node API service or through a full backend to like be able to send a transaction. But the main complexity is how does this website or web app need to issue transaction on behalf of the user? And I mean, the naive solution would say just as the secret key of the user, but that seems dangerous. Like you don't want to give random people your secret keys; they would just steal it, and then it's the end for you. You will have no money. So instead, what's used is the notion of a wallet for dApps, a wallet that allows dApp to act on behalf of the user. So on Ethereum, it's MetaMask, a browser extension called MetaMask. On Algorand, it's called Algo Signer. There are website versions. There are also like Wallet Connect that also is an option. So essentially, what it allows, this wallet are like things that the user install, they put their account there, and then the dApp connect to this wallet and ask the user, do you want to sign this transaction to do this thing? And the key is kept by the user and by the wallet. The dApp never sees the key. That's very, very important for security. I mean, you still need to exert caution because if you sign a transaction that sends all your money to somebody, too bad for you. Yeah, and the alternative, okay, so no need to talk about that. And I just want to show you really, really quickly what it looks like. So here's it's tiny man. So on Algorand, on Ethereum, you would call it Uniswap. And what tinyman allows you to do is exchange. Okay, sorry, I wanted to exchange algos for USDC for other tokens, but automatically, like no need to find someone. Oh yeah, exactly. Dan said, yeah, an example of bad transaction. Yes, OpenSea asset being stolen recently. So it's really something that you need to be careful. You should not sign randomly. So the way you use such a dApp that allows me to exchange my algo for USDC, which I may want to do, is I connect the dApp to my wallet. So here it's Algo Signer. If you used MetaMask, it will be MetaMask. I select my account. And now let's suppose that I want to exchange 10 algo for USDC. Okay, I select. It gives me some rate. This is testnet. That's why it's completely random number. And I want to swap. And now I need to send this 10. See, I want to do an exchange. I need to send this 10 algo to the smart contract. And to do that, I need to sign it. And that's exactly what will happen when I click confirm swap. My algo signer window, which is like MetaMask, my wallet, will tell me, do you want to sign this? And it shows me the transaction. So the first transaction is payment for the fee. So I need to pay for the fee. I approve. This transaction is actually no need to be signed. This transaction is I'm paying the 10 algo because I want to exchange 10 algo. I approve. And this transaction is also a transaction that doesn't need to be signed. I don't need to check too much. And now I can sign all my transactions. I type my wallet password, which is very secure. And 5 seconds later, I get my transaction. Hopefully, yes, exactly. So 5 seconds later, things happen. So when I type my password, what happened is that my wallet signed my transaction, send it to the dApp send it to the network, and now it's done. Now I have 14 more USDC in my wallet. I can even check it here. Okay, it's here. So it's a group of transactions where I received 14 more USDC. This is my account. And I sent 10 algos. You can see it here. Okay, so that's how it looks, and that's how it looks on Algorand. But that's very similar if you wanted to do it on any other blockchain. Okay, so these are a list of resources, and okay, I can have any question. Okay, so let me check. Oh, I see question already. Do we have a faucet to get algo used on the testnet? Yes. There is a faucet. Like just type testnet algo dispenser, something like this, and you have process. Yeah, that's completely fake algos. And you can also easily create your private network, like if you are accustomed to Ethereum, like Ganache, or you can create your private network too. That's also an option.
Oh yeah, question. Yeah, we have a question in the class, so hand the mic, go for it.
Yeah, so I guess with the finality being in 5 seconds, you kind of already mentioned if the network gets overloaded, then you can select different transactions. But I guess if the network gets overloaded and there's finality in 5 seconds, does that mean there's a chance that every 5 seconds I'm just retrying? And each time that a transaction fails, do I get my 0.001 kind of holding collateral? Do I get that back even if it fails, or do I still pay that?
Oh, okay. So that's a very good point. So on Ethereum, indeed, you lose your fee if the smart contract fails. On Algorand, actually, you never lose the fee until it's added to the blockchain, and also it's slightly simpler the way it works on Algorand. It's as long as you are above the fee of your node, a priori you will not be kicked out of the mempool of transaction. So it's not that the node will try to reorg the honest node, like the official software. We never try to reorg transaction. So it just we decide starting now, I want this minimum fee on the transaction. And if it's not, it will kick you out immediately. It will not start to reorg and take the higher fee. It will just still play by order. So if you got in because it was not congested, and just after you get in, it's very congested, like you will still be in the block, you will not be front-run by other people. Like, at least with the official software. Obviously, people can create their own software, and if they have enough power, they can start doing front-running and this kind of thing. But with the official software, this is not an option.
Cool, thanks. Any other questions in the class?
I might have one. So if we want to circle back to the Ethereum comparisons, because I think in this class, it's important to understand, like, why would you choose one platform over the other? And at least from what I've been seeing, Fabrice, thank you so much for this presentation, by the way. Specifically the language which you're using, PyTeal, but you mentioned the other one. Is it Reach? Yes.
Yeah.
This provably correct implementation of a contract is very appealing. And it's interesting that Reach in particular targets both Ethereum and Algorand. So this might be, at least in my mind, one really interesting way if you aren't sure which platform might want to work, but you are sure that you would like a provably correct contract. Maybe Reach could be something to reach for.
Yes, exactly. So Reach prove guarantee. So they don't yet prove guarantee. They don't yet prove that the smart contract against an abstraction of the virtual machine is secure. But they prove that the code that you wrote, if the compiler is secure, the code that you wrote will not end up into a locking fund, or you can also prove certain property on your code. So you can have guarantee on the code that you write. I think they are going further to be able to have a guarantee on the code generated, but it's slightly more complex. And that's, I think, the next step for them to be able to have guarantees on the code that is generated as opposed to the code that is given as input.
Makes sense. And then, so as you mentioned, like Ethereum, you can write some really complex things like Maker, for instance. You have a whole suite of contracts interacting with each other, and those calls can be very, very expensive. So on Algorand, maybe if you have a very complex program, but you're able to comply with the requirements in Algorand, so you have an independently complex, right? Could be very complex smart contract, but you're constrained then by what you actually can write. So if you're trying to force yourself to write a complex application that is constrained on this virtual machine on Algorand, it's much more intuitive, I suppose. It makes you do this, as opposed to Ethereum. You can do whatever you'd like, but it'll just cost you a lot.
Yeah, I think that's most likely true. Yeah, that's there is a limit on the complexity of each smart contract, so you cannot go overboard in and that hopefully makes things easier to verify.
Makes sense. Have you seen any good examples of people who have come from Ethereum and decided to rewrite and target Algorand, and what that story looked like?
Wait,
If you,
the issue is that I'm not sure what is public and what is not public. But
Yeah.
I don't think I have a very good example now. Right now, I don't.
yeah. Well, maybe if you think one up, I know we have this new channel in Slack that is between your Slack and our Slack in the class.
Yeah.
And I would love to maybe reach out and have some examples so we can go back and forth. For the rest of the class too, keep that in mind. Fabrice is an amazing resource. And I know we have something like a half a dozen other people who are doing amazing things in Algorand and are willing to help you guys with whatever you need. So look for that Slack channel. I'll go ahead and make sure that we post that here after this so that you can ask any questions you had that you couldn't get in here.
Yes. Yeah, I think that we have a huge amount of so there are many different resources on Algorand. So definitely you can contact me on the Slack. There is a forum. Let me show you where people ask questions, and usually if nobody answers them, I answer them. So that's very good because the community can enjoy it, like you can see. And there is a Discord if you prefer more like direct. So forum is more like a Stack Overflow type. Discord is more like discussion type. There are also like developer hours where so that's organized by the other company associated to Algorand, where they have like developer relation engineers that can answer all your questions. So like there are many different resources depending how you prefer to interact. That are possible, and there is also the just possibility to Slack me, and last year I also had meeting with the team, and so everything that works for you. Yeah,
That's awesome. Well, Fabrice, I learned so much, and this was immensely valuable, and hopefully for the rest of the class too. Whether you're technical or not, maybe we got a little bit too technical for the people who are not really into the comp sci and electrical engineering side of things. But I hope that gives you a sense of some of the things that really are fundamental to like what makes blockchain special and the kind of things you need to be thinking about. Because I don't know, Fabrice, about you, but it is a very low level thing because it needs to be, in the sense that you're optimizing for everybody across the universe who's running one of these nodes to run this program and store all this data forever, potentially. So that's why we have to get so nitty gritty about the details here. In the end, though, we get to make some pretty amazing applications that the user doesn't have to think about that at all if we do our job right. So I guess that's our job, understanding that the comp sci people on our teams really need to focus on this nitty gritty part to optimize, at least at a high level for this course. I think it's important to be aware of it, but don't get too bogged down in the weeds. Getting something that's production MVP, meaning that you can show this proof of concept or whatever it is that you'd like to build, I think that's enough for this course. But if you want to continue on, this is the rabbit hole you got to go down for sure. And conversely, on the other side, guys, if you're more on the business side and trying to tell this narrative of this application that you'd like to build, you don't need to focus super hard on the details, but be aware that they exist. You know, it's important when you move forward to not over-promise and under-deliver, right?
Yeah, I think that's a very good point. Like the one issue is really that blockchain is kind of the opposite of the cloud, because all the computer on the chain need to execute everything, and that's huge. Like this means that you are like asking like thousands, and maybe the blockchain is used millions of computers to compute the same thing. So there is sharding, there are technology to try to alleviate this, but still like there are this limitation, as opposed to when you use AWS, like you just rent one computer to do your job. That's a very different scale and complex, cost.
Right. Well, guys, I know we're right at time. I just want to make sure if there's any last questions or thoughts before we head off.
Yeah, I think before we do that, we can give a round of applause to Fabrice today. Yes. Awesome.
Super
Cool.
great. So glad you came.
Thank you.
All right. Well, then, guys, I think we'll close up here. I know that we'll see you again on Thursday, and for Tommaso to come back and do a session with y'all. And I'll be sitting in watching from afar. And I think that the next thing that we'll be doing on next Tuesday was just announced. We'll have Austin Griffith from the Ethereum Foundation, or at least formerly from the Ethereum Foundation, to talk about some smart contracting in low and no code environments. So now that we've seen this really low level understanding of how smart contracts can and should work, especially in the Algorand context, we can take that knowledge and move a little bit more into stuff that is easier to approach from the developer side on the Ethereum world, at least. So I think it'll be a good one.
Yeah.
Well, thank you all.
Awesome. Very
Bye.
cool.
See you again
Thank
next
you.
time.
Cool. I have one final announcement as well. So on Slack, I've also just updated the B courses, as well as sent on the Slack our upcoming guest mentors and guest speakers for all of Tommaso's side. So every single week, we're going to be having a guest lecture and then also the mentoring sessions. So all of that information is on the Slack, and you can go ahead and take a look at the mentors as well as the lineup. We also have secured an in-person guest mentor or guest lecture event for March 10th, which will be in the Sibley Auditorium. So please look out for the details. We're going to be sending out an Eventbrite, so register for that event. And we'll be having that event instead of that Thursday's class for March 10th. So yeah, that's it. Thank you
Thanks,
all.
y'all. All right. We'll see you on Slack until next time. Bye.
Cool. Thank you all.